Hello engineers, welcome back. In the previous video, we saw a new technique to play with arrays, which is the two pointers technique. Today, we're going to use that technique to solve a lead code question. Okay, let's get started. So in this video, we're going to solve the famous two-sum lead code question, and let's see how that question looks like. So this is the famous two-sum two question, lead code 167. And let's read out the question first. Let's try to understand what this is, and then we will think about our solutioning. Okay, so let's see. So this is the question. Given a one indexed array of integers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where 1 less than or equal to index 1 less than index 2 less than numbers dot length. So basically index 2 lies between index 1 and length of the array. Return the indices of the two numbers index 1 and index 2 added by 1 as an integer array index 1 2 of length 2. So this is what we need to return, an index array. So the array will have two numbers, index 1 and index 2. The tests are generated such that there is exactly one solution. You may not use the same element twice. So these are some constraints. So uh, let's break it down bit by bit, and then we'll see how to approach this. And it says your solution must use only constant extra space. So we're not allowed to borrow any extra memory from the RAM. Okay. So let's break it down. Let's try to understand this with an example. So if this is the numbers array, so we have an array of numbers 2, 7, 11 and 5, and they have given a target of 9. So the output they're expecting is 1 and 2. So what is the output? 1 and 2. So how did they come up with this? This is the explanation. The sum of 2 and 7 is 9. The sum of 2 and 7 is 9. Therefore index 1 is 1, index 2 is 2. We return 1 and 2. Now we know that array indexing starts from 0. So this is 0th index, this is index 1, this is index 2 and this is index 3. But they have said return the indices of two numbers added by 1. That's why they have added 1, and that is what they mean by one indexed arrays. Okay. So we need to add 1 and then return it. So if this the index of 2 is 0, this is 1. So if we add 1 to each of them, the output will become 1 comma 2. So that is the question. Okay, let's see another example. The numbers array is now 2 3 4, target is 6, output is 1 comma 3. So what is 1 comma 3? Index 1 and index 3. So 4 plus 2 is 6. So that's the explanation. The sum of 2 and 4 is 6, index 1 is 1, index 2 is 3. Okay, so this is the question. So let's take this and we'll see how we can approach this problem. Let's go to our whiteboard and let's make this a little bigger for you. So this is what they're saying. We're given an array of integers and we need to find two numbers such that they add up to the target, and when we find such numbers we need to return the indexes by adding one each. Okay, that's the approach. So this is our array. Let's call this an integer array 2 7 11 and 15. So whenever you are handling a question, maybe on Leet Code or maybe in an interview, so do not directly jump into the code. We will first try to provide um, an approach. We'll first try to think the brute force approach. So what will be the brute force approach for this? So we have an array 2 7 11 15, and the indexing is 0 1 2 3, right? So the brute force approach would be to compare each element with each other and add them up and see if they are adding up to the target. So if we can do like this, 2 plus 7 equal to 9, then we'll do 2 plus 11 equal to 13, and then we'll do 2 plus 15 equal to 17, and then we check the remaining ones. 7 plus 11 equal to 18, and then we'll do 11 plus 15 equal to 26, and things like that. So that is the brute force approach. We compare everything with every element with each other. So how would we possibly write this in code? We can make use of a nested loop, and then we can approach this. For example, we can do something like this: for int I equal to 0, I less than the size of the array, which is 4, I plus plus, and then we'll have an inner loop: int j equal to 0, j less than 4, j plus plus, and if array of I plus array of j is equal to target, so we have found our target. So we simply return I and j. So we are not simply returning I and j, we need to add 1 and return, because the question said this is a one indexed array, right? So we will simply create a new array and call it I plus 1, j plus 1. Okay, and that's it. So there are other constraints to consider, but I think this is a brute force approach. Okay, let's try to code it and see how it works. Let's go to Leet Code. So for solving this, I'm going to use JavaScript because we have not studied vectors yet. So I'm going to use JavaScript for this question, but bear with me, we'll study vectors soon, and we will solve questions in C++ directly. Okay, JavaScript is having pretty similar syntax to C++, so you may not be too confused that way. Okay, so let's get to it. Let's see how our brute force approach works. So this is the brute force method. So we are in a function. The function is having two parameters, numbers and target. In the numbers we have the array of numbers, and then this is the target. Okay, so what did we think? We thought we'll use a nested loop and we'll code accordingly. So let's go get to it. So I equal to 0, I less than numbers dot length. So since we don't know how many integers are there, we'll use numbers dot length. And I plus plus, we know the syntax, and the inner loop is j equal to 0, j also less than numbers dot length, and j plus plus. So what are we doing here? We are checking the sum of these two to match the target. So if numbers of I plus numbers of j equal to target, then we have found our answer, and we will simply return I and j. We will not just return I and j, we will have to add 1. Okay, so let's check if we have missed any constraint. One index integer of array that is already sorted in decreasing order. So we have not used the advantage of a sorted array. We'll see that. Find two numbers such that they add up to a specific target. Let these two numbers be blah blah blah. Okay, return the indices added by 1. So we have taken care of this, and return an integer array. Okay, the tests are generated such that there is exactly one solution. Okay, so this means that once we find a solution, we can return from the function. We don't need to check again. Okay, and we also don't need to check the condition where we don't find a solution. Okay, maybe we could have returned an empty array or something like that, but here they are saying there is exactly one solution, so we don't need to worry about that. And here they are saying you may not use the same element twice. You may not use the same element twice. So this is something we have not considered. So what does this mean? If the array is like this, let's say the array is like this, 0 comma 0 comma 1 comma 2, and let's say the target is 0. So this will be my I, this will be my j at some point, and I plus j will become 0. And what will be the returning index? These are my indexes 0 1 2 3. So 0 plus 1 is 1, 1 plus um, uh, here, if my j is here, no problem, this will become 1 plus 1 2. But when my j is here, when both my I and j are here, since we are using nested loop, we are starting both loops at the same starting position. We may encounter this case that I and j are same, so we will return like this. I and j will become 1 comma 1, and we will return 1 comma 1, and this will be wrong. Okay, so that is what they mean by you may not use the same element twice. So we cannot use the same element twice, so we need to add one more condition. Let's say my condition is if I not equal to j, oops, I not equal to j, then I'm okay, then you return this. Only when I is not equal to j. In this way I'm not using the same element twice. So that's it. So let's try to run this code and see if our basic test cases are passing. So our basic test cases are passing. So if we try to submit this code, we will not pass because this is uh, very long, and this is, the time complexity of this is huge. We'll discuss that. Let's submit and see what happens. Okay, so we can see here that 18 test cases have passed, but the 19th one has failed because time limit exceeded. So there are some use cases where the input is very large. You see the numbers array here, it is huge. And in order to understand why this has failed, let's understand the time complexity of our algorithm or the solution that we wrote. Okay, so what is this? This is a loop which is operating 4 times. This is another loop which is operating 4 times for every iteration of this. So the time complexity of this is 4 into 4. So that is 4 square. If the input array is very large, the algorithm becomes very huge and the time complexity becomes n square. And this is bad. This is bad because when the number is too large, the number of operations are just to the power of 2, right? Let's say there are 1000 elements in the array. 1000 into 1000 will become 10 to the power 6. So many operations. And imagine if the number is even higher. If the number is 10 to the power 6 and you're doing 10 to the power 6 into 10 to the power 6, it becomes 10 to the power 12. So many operations, the time limit is exceeded, and this is indeed very slow. So this was our brute force method. It worked for a few test cases, but we need to optimize it somehow. So let's see how we can optimize it. Okay, let's go back to our question. Now the question says this is a one indexed array that is already sorted in non-decreasing order, which means it is sorted in ascending order. Basically, they have just used a fancy word. Non-decreasing means ascending. Okay, and you can see they are all in increasing order. 2 3 4 -1 0 and things like that. Okay, so this is one piece we have not made use of. Let's see if we can solve this in a different way. Let's take the same array 2 7 11 15. 2 7 11 15, and target is 9. Target is 9, right? Yes, target is 9. Okay, so this time let's try to apply a technique to this. Instead of using brute force, let's try to apply a technique, and since we have studied the 2-pointer technique, we will try to use that technique. So How does the two pointer technique work? We can either put two pointers at one position and move them forward, or we can put them at either end and we can move them in the opposite directions and get them together. So let's put them here. So let's put I here and J here and see. So what will we see? We will try to add I and J. So if A of I, let's say this is A of I plus A of J. This is how we start. So what is the value? 15 plus 2 is 17. If we are having two pointers at each end and we are doing addition. We have one pointer here, we have one pointer here, and ultimately what we want to do, we want to find two numbers such that when we add them up, we reach the target. Okay. Now we have these two elements, and when we add them up, we are getting 17. So at this point of time, we need to check couple of things. First thing, we need to know how to move these forward. When to move I, when to move J. Okay, that is something we need to answer. And second thing is, what is our aim? Our aim is to find our target. Our target will come by adding these two numbers, right? Our target will come by adding these two numbers. So somehow we need to find a relation between these two. How is this addition changing my RHS so that we can reach the target? Okay, so this is my equation, right? A of I plus A of J is 17. Now what do I do with I and J so that I move closer to I, closer to target, move closer to target? Let's see. So I can do three things. One thing, I can move I can move J as a second thing, or I can move both I and J. I can do these three things, right? So let's see, if I move uh, I forward, what will happen? Now I got this 2 plus 15 equal to 17, and I want to move closer to 9. So if I move I forward, so the next number is 7. So 7 plus 15 will become 22. So we can check, have we moved closer to the target or have we moved away from the target? In this case, we have moved away from the target. We don't want this. We don't want this. We want to move closer to the array. So we will not move I. Let's try to move J and C. So we'll keep I constant and let's try to move J. So what is the J's previous value? This is 11. 11 plus 2 will become 13. So previously we were at 17. Now we are at 13. Have we moved away from the target or have we moved closer? So we have moved closer. From 17, we have moved closer. So this seems to be the right approach. This seems to be the right approach. So we are doing some kind of equation building, logic building, so that we meet our aim. Okay. So when we are using two pointer technique, we are essentially iterating over the array only once, right? So that way we have solved our n square problem. We were using n square here, and now we are not using n square. We are essentially doing n operations. We are traversing over the array only once. So that way we have solved the time problem. But what is the logic to find our uh, indexes so that we can return indexes, right? So we need to use that. So we have identified that moving J is giving us a better result. But what is the logic behind it? So in this case, 17 was greater than 9. 17 was greater than 9. So when this piece, when LHS, let's call this current sum. Current sum. Current sum is the current value of I and J. When we add them up, we get current sum. If when current sum is greater than target, when current sum is greater than target, we try to move J backward so that we move closer to J, move closer to target, right? So that is our one condition. If current sum is greater than target, we do J minus minus. And if current sum is less than target, you can imagine we will do simply the opposite. We will move I forward. Let's check. Let's say for a hypothetical situation, this was not 17, this was around 3. And if we moved I forward and this becomes 7. So 7 plus 15 becomes 22. And then we have moved closer to target, right? So that way we can build up our logic. Okay. And if we have found our target, if current sum equal to target, then we know what to do. We will simply return an array which will have I plus 1 and j plus 1. Okay, so this will be our logic. So we have solved the time complexity problem of n square by using two pointer technique, and by using two pointer technique we have iterated over the array only once, and because we have iterated only once, we somehow built a logic where we are able to achieve our target. Okay, and we need to uh, add up this condition as well, right? You may not use the same element twice, so we will simply check here if I not equal to j, only then we will return this. Okay, that is our last condition. So let's see, let's comment all this out, and now let's use two pointers. So how will we use that? Let's initialize I equal to 0, this is my first pointer, j equal to numbers dot length minus 1. So why numbers dot length minus 1? We need the last element. So if this is my array, the indexes are 0 1 2 3, so the number of elements are 4 and the last index is 4 minus 1. Okay, then we get the last element. So when we're dealing with larger arrays, we simply get the numbers dot length and we do minus 1 to get the last element. Okay, and let's call our loop. So when we are dealing with two pointers, as we have seen in the last video, we will not use a for loop, we will use a while loop, and while I less than j, as long as they have not crossed each other, we are in the loop. Okay, and this will be our exit condition, right? When I crosses j or j crosses I, it means that we have traversed the whole array, we have iterated over all elements of the array. Okay, now let's build our logic. We need something called current sum to keep track of what is happening. Let current sum equal to numbers of I plus numbers of j. Okay, and we will make use of this to move our pointers. If current sum is greater than target, that's what we said, right? If current sum is greater than target, we do j minus minus, we'll move j backward. If current sum is less than target, we simply do I plus plus, we move I forward. If they are equal, if current sum equal to target, we simply return an array of I plus 1 and j plus 1. But we need to add one more condition: if I not equal to j, only then you do this. Okay, so that will be my last constraint. Okay, let's see if we have done everything right. I less than j, current sum is the addition of these two. If current sum is greater than target, which means we are very farther away from target, we reduce the j value. And if current sum is too small, we need to move closer to the target, we'll move I. And if current sum equal to target, we will simply return I plus 1 j plus 1. Okay, Let's run and see. Okay, so our code is accepted. Let's submit and see. And our code is working perfectly fine. Okay, so just to recap, we have used a brute force method, which is having a time complexity of n square. And now we have used a two-pointer technique, which is now having a time complexity of n. We are using the while loop and it is traversing over the array only once. Okay, that way we can use the two-pointer technique to optimize our solution. Okay, so that's it from this video, guys. Thank you so much for watching. And in the next video, we will try to solve another leet code question, but this time we will try to use the concept of moving two pointers in the same direction. Okay, so stay tuned for that. So that's it for this video. Please leave a like if you have found this video helpful, and if you have any question, please ask me. And we have solved this in JavaScript, I know. We will soon learn vectors, and we will use C++ going forward. Okay, so thank you so much for watching, guys. I will see you in the next one. Cheers.